first time I've ever seen one. They are extraordinary. They have really long heads. I guess that's how they got their name.
Yeah, look at the size of him.
Doesn't seem at all afraid, does he?
Not at all. He certainly moves in the current better than we do. Gosh, I can't believe the size of it. Certainly doesn't seem too bothered by the bubbles.
No, he doesn't.
Look at that. Oh, what a beautiful animal. Well, he's off looking for a lady friend, probably.
On the Great Barrier Reef, it's the height of the breeding season. The turtles are busy digging their nests. This green turtle is just one of thousands that have lumbered ashore.
You know, I've seen a lot of turtles underwater while diving, but this, being so close to one laying eggs, it really does give me a new appreciation for them.
It's just wonderful. She doesn't seem in the least bit bothered by us, does she?
No, not at all. Certainly still laying eggs. Well, considering all of the effort she's gone through to climb the beach and dig this pit, I think I would keep laying too.
It seems extraordinary that she waits 40 to 50 years before she starts this whole reproductive bit.
That is a long time. And then she may wait another 8 years before laying eggs again.
Eggs are really soft and leathery, aren't they?
It's a good thing. Look at how they drop on top of one another. I think she would have an omelet down there otherwise.
She goes, she's finished.
Covering them up. I have a feeling if we stay here much longer, we're going to be part of the egg chamber. It's me.
Their eggs safely buried, the exhausted turtles must get back to the sea as fast as possible. It's a matter of life or death. They have to be in the water before the sun gets too high. Otherwise, they will simply overheat and die.
She's had a rough night. We're in Australia, and the reason is because the Earth's greatest reproductive spectacle is about to occur along the Great Barrier Reef. We've come from the other side of the world in the hope of witnessing it.
Ah, but not yet, even though the turtles are busy. Turtles actually mate in the water, but as we've seen, they come up on land to lay their eggs. But almost all other marine animals have to do the entire process in the water.
And it's those animals we've come to see. So what is the Great Barrier Reef? It's a natural structure, a living structure, that stretches over 2,000 kilometers. But rather than being one continuous coral reef, it's broken up, forming a chain of reefs of every shape and size imaginable. This is the largest structure built by any animal on Earth, including man.
Reefs grow well where the water is warm and clean and where there's reliable sunshine. Corals absorb food from algae living within their tissues. They also feed directly from the water, so they thrive where they're exposed to currents that wash food over them.
Great. Currents can be very powerful, as well as a great way of moving around. Currents supply the reef with their primary source of food, as well as being very important to reproduction and the distribution of offspring. And they can provide for a little fun. Martha, catch! Don't worry, it's completely harmless and it'll dissipate soon.
That's extraordinary. Certainly shows the current. But just imagine for a minute that you were a tiny animal drifting in this current. You'd be shooting along. And this water is literally teeming with life. Eggs, sperm, microscopic plants and animals. It's called plankton. And once the eggs are fertilized, they quickly develop into larvae, are transported further afield by currents, and if they survive that stage, settle out from the plankton and begin to grow.
And the physical structure of a coral reef is the perfect place to do that.
Currents are constantly moving through the reef, sometimes rather briskly. At first glance, the reef may appear to be solid, but in fact it's riddled with nooks and crannies, which allows a tremendous variety of animals to coexist in surprisingly small areas. Because this three-dimensional structure is so convoluted, fish can thrive alongside their predators. Larger fish find shelter underneath living coral, smaller ones in it.
But living cheek by jowl in a mixed community like this doesn't necessarily mean that finding a mate is easy. To reproduce successfully, all animals must ensure that sperm meets egg. For some, like sharks, the first step is to find a partner.
This is where the reef frontiers with the ocean, the Great Barrier. And this, of course, is where the sharks are.
Here comes a gray reef and a white tip. They seem like their muscles are always tense, which tends to make mine the same way.
Sharks have the luxury of being mobile, which means they can swim to find their mate. And once they've found them, to ensure successful mating, they use internal fertilization, unlike most fish.
Well, that's all well and good if there happens to be a male around. The female's ready, but that isn't always the case. Though some sharks have developed the ability to store sperm, which means that they can take advantage of an encounter whenever it may occur, and the female will hold that live sperm in her body until her eggs are ready. Then she fertilizes herself.
Oh dear, he's getting close. Honestly, I'm not tasty. I really mean it. The other big difference between shark and fish is that shark invest a lot of time and energy into very few young. So that when the young actually emerge, they're miniature adults, so to speak, and really fend for themselves from that point on.
Not all reef animals reproduce by internal fertilization. Indeed, very few do. There are other ways. Some butterfly fish form a stable, long-term partnership. So whenever the female expels her eggs, her mate is always around to fertilize them. The eggs are then abandoned. There's no parental care. But in between bouts of spawning, the pair stay together, defending their territory.
Surprisingly, sex change among reef fish is fairly common. The orange fish in front of me are entheus, and they all begin life as females. These are females down at the bottom. Above them is a solitary male of a larger purple fish, and he fertilizes the eggs of the entire harem. Now, if the male were to die or leave the group, the dominant female would immediately begin changing color, size, as well as sex organs and become a functional male. The advantage of this system is that for any harem, there are always available males and females for reproduction. glorious fish.
They are huge fish, aren't they?
Could not agree more. They're absolutely enormous, certainly bigger than we are.
It's not just the little fish like the anthias that go in for sex change. These giant groupers do too. And like the anthias, these fish start off life as females, and by the time they get to this size, they're functional males. Wow. Are you friendly? It's alright. It's a friendly hen.
I think he enjoys that physical contact.
Fabulous spots. You have to be careful though, their mouths they're pretty vicious inside, don't they?
That's the problem, isn't it?
Rows of jutting back teeth. Rather intimidating. I think he likes being tickled under the gills, don't you?
Oh! I just got accidentally pushed. I can't help but noticing some of the passengers that they're carrying. These thin fish swimming around the groupers are called remoras, usually associated with larger reef predators like sharks. These groupers are large enough to support them as well. They're not parasites on the groupers. They just hitchhike a ride with a little sucker disc, take advantage of any tidbits of food that might pass their way. Should clean her ass on this one as well.
This might look suicidal, but the cleaner wrasse knows it's safe while it feeds, helpfully picking off parasites and loose scales. Other, much smaller fish have found ways to reproduce which greatly increase the chances of survival for their offspring. Like the anthias and groupers, these anemone fish can change sex, but they form long-term partnerships as well. The whole group lives in the anemone, where it's protected by the stinging tentacles.
This one is really special, because just over here are some eggs. What happens is, the male bites back the anemone, entices the female down to lay her egg, which she does, several hundred or so. And the critical thing is, they tend the eggs for about a week until they're ready to hatch, and that vastly enhances the survival. By tending, what I mean is they aerate the eggs and pick off the dead ones to stop contamination and so on.
Others don't tend their eggs. They leave things to chance and compensate by producing millions of eggs and sperm in a spawning frenzy. Here, much of the spawn is being eaten by the larger fish, but enough will survive to develop into the next generation.
These chromis are also spawning, but they're more cautious. They lay their eggs on the bottom where they can be protected. The yellow male entices a female away from the group and down to a patch he has just cleaned. She deposits her eggs and leaves. He stays to fertilize them.
When fish are ready to reproduce, they can go in search of a mate. But because corals are fixed to the reef, they've developed two different ways to reproduce. Their sexual reproduction is a spectacular event for which we had to wait. But most coral growth is asexual, with the established corals simply cloning themselves to form these massive structures.
Coral grows throughout the year, but as it grows, it's continually eroded. Parrotfish are one of the main culprits. They scrape at the coral and bite off chunks to get at the algae inside. In doing so, some of the coral is eaten. It later emerges as sand.
That's amazing. Everybody's doing it. First the turtles and the fish were waiting for the corals, and now the mollusks are at it.
Well, it is the spring in Australia. I guess it's that time of year.
Ready? It's gonna go.
You can see them slowly open up.
Yes! But completely obscured by it.
I cannot believe that.
No wonder the water's murky.
Giant clams are hermaphrodites, which means they can produce both sperm and eggs. One in front of us is releasing sperm into the water, which will trigger the surrounding clams, God, look at that, to release their eggs. But they don't release sperm and eggs at the same time. They do it separately so that they, as individuals, don't fertilize themselves.
Oh, look at it coming out now. It's just trickling. Sometimes it comes in a great big shoot. Look at that. Like the fish that we've been seeing, giant clams are broadcast spawners. But unlike the fish, they can't move around. They're stuck to the reef. So they have to pump out very hard all the sperm and the eggs, so the eggs get the elevation and can drift along and find another bunch of sperm and eggs from another clam. God, it's going up, what, 2 meters?
At least.
That's amazing.
Still going.
Once an egg from any of these animals has been fertilized, it spends some time drifting in the water as a developing larva. If it survives that stage, it then has to settle somewhere on the reef. To get there, it runs the gauntlet past thousands of plankton-eating fish.
Imagine having to get through that on your first day of nursery school.
No, thanks. Or from a different point of view, imagine us having to swim past hundreds of hungry mouths the size of airplane hangars.
Yeah, but if they get through, they quickly develop into the tiniest little fish.
Space on the reef is limited, so much so that any available surface or hole is soon occupied. The same is true out on the deeper reefs, and some of them are artificial. If, while navigating a boat between the reefs, it hits one, it becomes one. Very quickly, the doomed vessel becomes a thriving reef community by first attracting small and then larger animals. Comparisons between artificial and natural reefs are easy to make. The living part of a natural reef is really just a thin veneer of tissue growing over rocks and dead coral. Here, the ship provides the superstructure for these plants and animals to grow on.
By the time we'd reached the bows, the current had picked up and the wreck was alive with animals. Huge bull rays seemed almost to be guarding it.
The ship settled in 100 feet of water, and briefly, so do turtles. Clams and mussels live in the sand flats surrounding the wreck, providing food for snappers, who are more commonly seen huddled under the twisted metal.
Coral reefs support delicately balanced communities. Everything's fine as long as this balance is maintained. But if the population of one predatory animal explodes, it can have devastating results. Here on the barrier reef, the crown-of-thorns starfish has done just that.
Like this one's spawning. Unlike the giant clams, starfish have separate sexes. They're either males or females.
This one's a female, and she'll produce 30 or so million eggs. And if this is a successful spawn, and just a fraction of all these eggs survive, it could be really bad news for this and the surrounding reefs.
Periodically, their populations explode, and they're like a plague, wiping out huge areas of coral. You can see here a little patch already starting to go. That's not necessarily a bad thing, because by killing the coral, they leave behind very good surface for new animals to colonize.
Let's have a look.
Yeah, I've had a nice close look.
Thanks, Mike. Extraordinary. This must be what a coral sees when it's under attack. Crown-of-thorns feed by turning their stomachs inside out and digesting the living coral polyps. And when it's finished, it sucks its gut back in and leaves a white skeleton.
I wish you could see what that looks like crawling around your head from out here.
You should see what it looks like from in here. It's extraordinary.
Even with the crown-of-thorns devastation, the reef endures, and our witness to its reproductive success was far from over.
Many creatures spawn after dark when there are fewer hungry mouths around, and they choose the days in the month when there are strong tides to help carry their spawn away from the reef's predators.
We've been promising a coral spectacle throughout the program, and finally the time has arrived. Amazingly, corals stretching over 1,000 miles may spawn at virtually the same time.
The sex lives of these corals are tightly synchronized to water temperature, the moon, to light and to tides. And only when all these factors are in exactly the right phase together do corals respond by releasing countless millions of eggs and sperm.
And if our information is correct, it should begin at any moment.
It's really happening, just like they said it would.
Right on schedule. I can't believe it. You can see them forming right at the tips, can't you? And just popping out.
It's like miniature polystyrene balls, aren't they?
Actually larger than I expected as well.
Yeah, much more visible. Like an upside-down snowstorm.
Well, from where we live, this is the upside upside down half of the world, isn't it?
But when you think about it, this whole colony is made up of thousands of individual polyps, each its own animal. And they've got it together to spawn at the same time. And this species, 100 yards further along, is spawning. And 100 miles further away is spawning at the same time.
This has to be one of the most impressive queuing systems in the animal kingdom. Pretty clever spawning technique as well, considering each one of these tiny spheres is actually a carefully crafted bundle of eggs and sperm.
Efficient packaging.
Efficient spawning. Look at this around us. These things hit the surface, they'll break apart, and it's easy to understand how this colony will cross-fertilize with its neighbors, isn't it?
Yeah.
Look at all that.
I know the fish are having a field day.
If they survive the fit, the eggs are fertilized and become minute swimming larvae. The currents may take them great distances before they settle back onto the reef, forming new coral colonies.
I'm a true champion.
Corals have developed this mass spawning technique because they're immobile and they can't actively seek out a mate. By overwhelming would-be predators with such an abundance of food in such a short period of time, greatly increase their offspring's chances of survival.
And it works. It's quite a thought that from such tiny, vulnerable beginnings as these, the vast expanse of the Great Barrier Reef itself is being created.